So student, today we're going to see two problems related to NCERT. Okay, so here the first problem. Show that angle of an equilateral triangle are 60 degree each. That means it has given you that ABC is an equilateral triangle and you need to prove that each angle is 60 degree. Okay, we know the property of equilateral triangle is this one, but right now we're going to prove this property. Okay, so how? So here it is given that ABC is an equilateral triangle. Okay, or directly instead of going for a given to prove or like that, you can directly start like this because it is not a theorem. You start like this. We have ABC is an equilateral triangle. This implies by definition each sides are equal to one another. Okay, this means we can write AB equals to BC, and separately we can write AB equals to CA. Now look at here. Angles opposite to equal sides are equal. Here the sides are equal. That means their angle must be equal. So here AB equals to BC. That means angle opposite to AB is what? Angle C. Angle C equals to the angle opposite to BC. So look at here, BC is this one and A is what? This. So we write here A. Similarly, same concept, AB opposite to AB is what? C, angle C, and opposite to CA is angle B. We write here the reason. Angles opposite to equal sides are equal. Now from this two we can say that angle A equals to angle B equals to angle C. So how? Things which are equal to the same thing are equal to one another. So here angle A equals to angle C and angle B is equals to angle C. That means all threes are equal. But what we know, angle A plus angle B give this one number 1. Angle C equals to what? 180 degree. How, sir? Because if we add this interior angle, you will get 180. So we'll write here angle sum property. Okay. So from 1 to 3, not 1 to 3, you can see from 1, angle A plus angle B can be written as angle A and angle C can be written as angle A. Okay. This implies 3 times of angle A equals to 180 degree. This means angle A equals to 60 degree. Now from 1, if angle A equals to 60 degree, that means angle B and angle C must be 60 degree. So this implies angle A equals to angle B equals to angle C equals to 60 degree from 1. Hence what? Angle of an equilateral triangle are 60 degree. Okay. Hence each angle of an equilateral triangle are 60 degree. Okay. Okay, next problem will go. So here we have the problem. Two sides AB, BC and median AM of a triangle ABC are respectively equal to the side PQ, QR and median PN of triangle PQR. So what they have given here? So here they have given that AB equals to your PQ, BC equals to QR, and third AM equals to PN. These three things they have given. Okay. Now we need to prove that ABM, this triangle is congruent to this triangle PQN. Okay, and next, after showing this one, we're going to show ABC triangle congruent to triangle PQR, these two. Okay, so we'll start. So here proof. So in triangle ABM and triangle PQN, so what we have, AB equals to PQ, AB equals to PQ as it is given here. Next, AM, so here AM equals to PN and it is given here. AM equals to PN given. And the third one, you can see BC equals to QR. But where is BC, sir? We don't have. Okay, you write first. BC equals to QR. Okay. And we know that half of equal are equal in Euclid geometry. Remember? Exams, half of equal are equal. That means BC by 2 can be written as QR by 2. And look at here, BC by 2 means half of BM. Not half of, means BM. This is why, sir? Because AM is a median and median divide the side into two equal part. If your AM is median on BC, that means BM equals to CM. Similarly, here PN is a median on QR. That means QN equals to RN. That means half of BC is BN and half of BC is CM. So our demand is BM. So we'll choose BM. We'll not choose CM. Similarly, from this side, we'll choose QM. That means we can write here BM equals to QN. And look at, we have here BM equals to QN. So we'll write any reason. Yes, you have to write the reason. How could you say that this half of BC is BM? So you need to say here that AM and PN are median of triangle ABC and triangle PQR respectively. Okay, now we can see that this equals to this part equals to this, and this one equals to this. So by SSS criteria, therefore by SSS criteria, we can say that these two triangles are congruent. Okay, now what? Second one. So I will go for second one. So before going, let's see that will this congruent part will help us to find any other part? Yes, angle B equals to angle Q. Why? Angle B equals to angle Q. You can see that corresponding parts are what? Equal. So here we'll write here CP CT. Okay, corresponding part of congruent triangle. Now in triangle ABC and triangle PQR, see, we have AB equals to PQ, then BC equals to QR, given, you write here given, and the third one, angle B equals to angle Q, above proved. Right now only we have proved here. Okay, therefore you can say that triangle ABC congruent to triangle PQR. Can you guess by which criteria? Okay, let's see here. AB equals to PQ, S, BC equals to QR, S, and you can see that inside part A, that means SAS, SAS. So by SAS criteria, we can say that these two triangles are similar. Okay, one more problem we're going to see. Here you can see, in a triangle, if bisector of an angle divides opposite side of a triangle in two equal parts, then prove that triangle is isosceles. That means what they are saying? They're saying that ABC is triangle and AD bisect angle A, okay, and BD equals to CD. That means AD bisect angle A also and bisect BC such that BD equals to CD. If this thing happen, then AB equals to AC. That means ABC is an isosceles triangle. You need to prove this one. Okay, so let's see. So what they have given, first we'll write this one. So in triangle ABC, AD bisect angle BAC. Okay, that means angle BAD equals to angle CAD. Okay, next it also says that BD equals to CD. This one has given. Okay, so here to prove, what we need to prove that ABC is an isosceles triangle. That means AB equals to AC. If any two sides are equal, then we can say that triangle is isosceles triangle. So we're going to use the property. Okay, not a property, definition. So here, any construction we need, sir? Yes, here we need construction. Okay, so let's take a construction. We'll extend AD to E. Okay, it's our choice, such that AD equals to ED and join AC. So we'll write here, extend AD to E such that AD equals to ED and join C. Okay, so we're going to start proof. So what we're going to do, see, we cannot prove directly, so we need one more triangle to prove that AB equals to CD. So our target this time is to show that these two triangles are congruent. Okay, so let's take in triangle ADB and triangle EDC. See, order is very much important. We need to take this only. Okay, so let's see what things we have. We're going to use that one. See here, AD. Okay, AD equals to ED right now only. So we'll write here AD equals to ED by what? By construction. Okay, next let's see what we have. Yes, you can see that BD equals to CD. So here BD equals to CD, it is given. So we'll use here BD equals to CD. Okay, next third one, can you guess? This one equals to this, this one equals to this. Now 2S we have, then which criteria we have? Yes, SAS. That means we need to show that these two triangles are equal. Can you say? Yes, by vertically opposite angles. So we'll write here angle ADB equals to angle EDC. See the order, ADB EDC. Have you seen? Order is very much important. By vertically opposite angles. So therefore we can say that triangle ADB congruent to triangle EDC by SAS. Now what we're going to do, we'll use its property. Okay, or we can say that by definition we'll use the corresponding parts are equal. So which part we're going to use here? We'll can say that this angle, we'll choose angle. Why, sir? We'll show this angle equals to this, and we know that these two angles are equal. That means we can say that this angle equals to this. And in isosceles triangle, remember, not isosceles triangle, side opposite to equals angles are what? Equal. We'll use that concept. Okay, so we'll use this one and see that BAD. So we can write here angle BAD. So BAD we are taking. So we need to take here BAD, CED, angle CED. See here, CED. Have you seen? Matching. But order, keep the order properly. Okay. So CP, CT. But what? But angle BAD equals to what? Or directly we can write, instead of writing this one, already we have this one, you write here, this is your number 1. Okay, so say here that angle CAD equals to angle CED, and say from here, from 1. No need to write extra word. Okay, so from 1 you can see that now in triangle you can see this one, CAD equals to CED. That means two angles are equal. If two angles are equal, that means after this, okay, after this here, this imply opposite angle. See here, the sides are equal, that means opposite sides are equal. So this side is what? Which one? This one we can say. Okay, so we can say here, what we can say, this part. Okay, one more thing we need to write. Okay, simplicity, you say here that is AB equals to EC. Okay, use this one also. We're going to use this part, CP, CT. Okay, keep this one. Number 1 we have already taken, number 2 you keep it here. Okay, so here we can say that opposite of this one is what we have written here, EC, right, equals to what? This one, that is CAC. This imply EC can be written as AB, and here you mention from 2. So look at here, our target AB equals to AC, and we have here AB equals to AC. And this imply if in a triangle two sides are equal, then we can say that triangle ABC is an isosceles triangle. Okay, thank you.